Assalamualaikum and hello everyone. My name is Afrina Najwa binti Amin Nazrin, and today our group will be presenting our findings on the orifice coefficient experiment. An orifice is an opening of any size or shape in a pipe or at the bottom or side wall of a container through which fluid is discharged. Flow measurement by an orifice is based on the application of Bernoulli's equation, which states that a relationship exists between the pressure of the fluid and its velocity. The flow velocity and discharge calculated based on the Bernoulli's equation should be corrected to include the effects of energy and viscosity. Therefore, for accurate result, the coefficient of velocity, coefficient of contraction, and the coefficient of discharge should be calculated for an orifice. The orifice coefficient, which a dimensionless number, is used to calculate the flow rate through the orifice. The objective of the experiment is to determine the coefficient of velocity, coefficient of contraction, and coefficient of discharge of two small orifices in the lab.
My name is Nur Izati binti Muhammad Karsa. The apparatus that used in this laboratory is hydraulic bench, needle, heat tank, board, and orifice plate with O-ring.
First, clip the paper on the board using the magnet. Then, measure the diameter between each needle and the diameter of the orifice. Then install it to the heat tank. Connect the valve to the pump outlet and turn on the pump and let the water flow up until the head become constant. After the head level become constant, measure and record the head level. Then, adjust the needle to touch the water without interrupting it. Mark the needle on the paper to get the horizontal and vertical distance. Then, record the time taken for the water jet to fill up 500 mm of the measuring cylinder. Repeat the procedure using different orifice diameter.
Hi, my name is Nurul Imshada binti Muhammad Zamri. Here is the data that we get from this experiment. We get the orifice diameter, distance in x, distance in y, head level, y raised to the power of 1/2, which is y is a distance in y, h is head level. We also get volume and time to calculate the discharge using volumetric rate formula. And then we can calculate the h to the power of 1/2. There are two diameters that we use, which is 4 mm and 10 mm. Here is the graph distance in x versus y h to the power of 1/2 that we plot. The blue line is for 4 mm diameter orifice and the orange line for 10 diameter orifice. This is the formula that we use to calculate the coefficient of velocity, coefficient of contraction, coefficient of discharge. Firstly, we need to find the velocity of orifice using formula Q equal to AV. After we get the value of velocity, we can calculate CV using formula V over square root 2GH, and we get the answer of 0.802. Then, after that, we can calculate the CC using formula Q equal to CV A multiplied by A multiplied by square root 2GH. Then we get the answer is 1. Lastly, we can get the value of CD using formula CV multiplied by CC. Then the answer is 0.802. For 10 mm diameter, repeat the same step as a 4 mm diameter. After the calculation, we get the value of CV, CC, CD. For 10 diameter, CV, the value of CV is equal to 0.397. CC is equal to 1. CD is equal to 0.397.
My name is Siti Sarah binti Muhammad Alwi. So today I will talk about discussion of this experiment. After doing the experiment, we found that the determination of coefficient such as velocity coefficient CV, contraction coefficient CC, and discharge coefficient CD play an important role in understanding fluid flow. So from the experiment, we have calculated CV, CD, and CC values. For CV values of 0.802 for 4 mm diameter of orifice and 0.397 for 10 mm orifice indicate how effectively each orifice size convert the pressure energy into kinetic energy of the fluid. The higher CV values indicate less energy loss due to friction. Net, the CC value of 100 for both orifice diameter suggests a minimum contraction beyond the diameter of the orifice itself. The discharge coefficient CD combines the effect of CV and CC with a value of 0.802 for the 4 mm diameter of orifice and 0.397 for 10 mm of orifice. So from that, CD values confirm the superior efficiency, translate into more accurate to flow measurement.
The orifice coefficient experiment provided valuable insight into the behavior of fluid flow through an orifice and the factor that affect it. The results showed that the orifice coefficient is influenced by the diameter of the orifice. The difference between the experimental result and the theoretical value highlight the importance of considering sources of error in the experiment and the need of precise measurement techniques. This experiment is important for various industrial processes and systems where it is necessary to understand and control restriction to flow caused by an orifice.